Alright guys, we talked about conversion factors, well, we talked about dimensional analysis in the last video, which is the same as unit conversions or conversion factors. It's just the introductory aspect in the last video. And then this video, what we're going to do is we're going to actually see some conversion factors. We're actually going to convert some units. Alright, so let's read the question. It says, the Star of Africa is a diamond with a mass of 106.04 grams. It wants us to convert this measurement from units of grams to units of milligrams and kilograms. And again, this seems like probably a random or arbitrary task, but the point that we're trying to get here is we want to see that unit conversion from 1 unit of measurement right here, right? Okay, let's go ahead and circle that. 1 unit of measurement right here to milligrams and grams, okay? So we want to make sure that we understand how to go smaller in terms of milligrams, and we're going to see how to go larger in terms of kilograms, right? The amount's going to stay the same, but the unit of measure is going to vary, right? Okay, so let's go ahead and get started. All right, so one of the things you've heard me mention over and over again is that a division problem is a fraction, is a ratio, is a rate of change, is a slope, so on and so forth. So what we need to do is we need to get a ratio, a relationship between grams, right, and milligrams. So what we'll do is we'll start out with what we need. What we need is milligrams. Whoops, there we go, milligrams. So we'll put milligrams on top. 1 milligram, right, is how many grams? What's the relationship there between milligrams and grams? Well, the answer is there's 0.001 grams per 1 milligram, right? So we have a relationship. So we could either write it this way, or we could say also that there's 0.001 grams per 1 milligram, right? Either way is true. Both are true statements, okay? But what we're looking for is milligrams. We already have grams, so we want the numerator to be in milligrams, okay? Because the numerator is what we have, right? And let me explain what I mean by that. Let's say that we had a piece of pie, all right, or a pie cut, and we have 1 piece out of 4. The numerator is 1, the denominator is 4. We have 1. That's what we're concerned with, is what we have. And that's what I mean when I'm saying that. So let me just clear this out. So we have 1 milligram per 0.001 gram. So our next step will be to look at what we started with, 106.04 grams, right? And then we're going to make that a fraction. So that is equivalent to 106.04 grams over 1, right? That's legit. Now, we're going to multiply that by our ratio that we created. So we want milligrams, so 1 milligram is equal to how many grams? 0.001 grams, right? And now we see right here something that we talked about in the last tutorial. We talked about our ability to cross-cancel units just like we can numbers, right? And if you forgot about that, just go back to the video labeled Dimensional Analysis and go ahead and review that, okay? And this is going to be Dimensional Analysis 2, or Part 2, okay? So now we've cross-canceled grams, so we've gotten that unit out of the equation, right? So now we have 106.04 multiplied by 1 milligram, right? Multiplied by 1. So we can go ahead and do that, and that's just going to be 106.04, right? Okay, so when we combine these terms, we have 106.04 milligrams over 1 times 0.001 grams, and we know that that's the multiplicative identity right there, right? 1. So we just write the 0.001 grams. And this is going to be equal to, and we didn't need those parentheses, I didn't mean to put those there. Let's go ahead and get rid of those. When we go ahead and carry this out, we just simply look at the number of decimal places, 1, 2, 3, 1, 2, 3, and we see 106,040 milligrams is equal to the original amount of 106.04 grams. So we can see that there was a conversion that was done, and of course we could have just said, well, let's just look at this decimal and make the conversion by moving the decimal points, and that's absolutely legitimate. But I wanted to show you that conversion factor process. I wanted to show you the process of cross-canceling those units of measurement and combining the terms mathematically. All right.